Okay, a very good morning all. Today I am going to explain about finite automata to regular expression conversion using Arden's and extended Arden's theorem. Right. Using this Arden's theorem, so then we can write the state equations for the given DFA. So let us directly go to a one problem on this finite automata to regular expression conversion. Finite automata to regular expression conversion. So then how we can convert the finite automata? Let us take one problem, right? Consider the transition system. Consider the transition system given below and prove that the strings recognized are as a plus a into b plus a whole star b star a into b plus a whole star a, right? So now we need to prove this is the regular expression for this given DFA. Now this DFA has three states, Q1, Q2 and Q3. Q1 to A is Q1 and Q1 to A we are also reaching to Q2. Q2 to B we are reaching to Q1 and Q2 to another B we are reaching to Q2, and Q2 to A we are reaching to Q3 and Q3 to A we are reaching to Q2, right? This is the given DFA. Now we have to prove that for this DFA the regular expression is this one, right? So now we need to prove this, right? Let us see that, right? The state equations for this. What are the states we have in this given DFA? Q1, Q2 and Q3. That we have to write the Q1 equation means what? So then what is the reachability to Q1 in the given DFA? So right, so in this DFA how you can reach to this Q1, from where you can reach to Q1? We can reach to Q1 from Q1 to Q1. See, this is Q1 to Q1, how we are reaching with input A. With input A we are reaching to Q1 to Q1. So we can write that equation as, so in the, okay, so we are writing that equation as Q1 with A we are reaching to Q1 plus, and what is that another path we have to reach to that Q1? That another path to reach that Q1 is from Q2. How we are reaching from Q2 to Q1? Q2 with B we are reaching to Q1, right? Q2 with B. Now we can also add Q2B. Q2 with B we are reaching to Q1, right? And is there any other path that we have to reach to that Q1? So then see that in this, is there any other path from Q3? Can we reach to Q1? No, we cannot reach. And how we are reaching? Because Q1 is initial state, so since Q1 is initial state, with epsilon also you can reach to this Q1. So we can also add epsilon to this Q1 equation, and because Q1 is the initial state, so we can also reach to this Q1 with epsilon. So this is the state equation for the Q1. Q1 is what? Q1A plus Q2B plus epsilon. What is the meaning of this? We can reach Q1 with the input A and Q2 with input B, or else since that Q1 also is initial state, we can also reach with epsilon mu also. Next, what is that state equation of Q2 then? How we can reach to Q2? Starting from Q1, how we are reaching to Q2? Q1 with A. Q1 with this path A we are reaching to Q2. So we have to write Q1A. Q2 is equal to Q1A. How we are reaching from Q2 to Q2? Is there any self loop that we have from Q2 to Q2? Yes, there is a self loop. Q2 with B. So Q2 with B we are reaching to this Q2. So then we have to write that Q2 with B. Okay. Next Q2 with B, and since this Q2 is not the initial state, we cannot add epsilon. And let us see that, do we have path from Q3? Yes, from Q3 with A we can reach to this Q2. q3 with a, we can reach to this q2. So we can also write q3a. Now this is equation 2. Next, how can we reach q3? Do we have any path from q1 to reach to q3? There is no path from q1 to q3. Do we have path from q2 to q3? Yes, that is what, q2 with a, we can reach this q3, q2a. It means that q3 is what, q2a. q3 is q2a. Now this is third equation, right? So now in this three equations, now we have written three equations from the given DFA. But what is the final state here? Q3 is final state. So we need to find out regular expression for Q3, right? That will be the regular, we need to find a regular expression for Q3, which will be the required regular expression for the given DFA. Why we are choosing only Q3? Why not Q1, Q2? Because Q1, Q2 are not the final states. Only Q3 is the final state. So we have to reach to this final state. So then when you are finding out a regular expression for Q3, that will be the regular expression for the given DFA, right? So now what is this? Q3 equal to Q2a. Now where you can substitute this equation? You can substitute this equation Q3 as Q2a in the equation 2. Now let us substitute 3 in 2, right? Now let us substitute equation 3 in equation 2. Let us substitute equation 3 in equation 2, right? What is this equation 3? What is this equation 3? Equation 3 is what? The previous one, Q2a. Now we can substitute this in this Q2 equation. What is Q2 equation? Q1a plus Q2b plus Q3a. Q2 is Q1a plus Q2b plus Q3a, right? That is Q3, but instead of Q3 what you can write? Q2a. So Q2a and there is one more a, so it is Q2aa, Q2aa, right? Now we can simplify this like this: Q1a plus, take Q2 as common, then b plus aa. Now Q2 is, it is like R, it is Q, then it is R, then it is P. Now how this equation is looks like? It is like R equals to, so it is like R equal to Q plus RP. This is what? Arden's theorem. This is called as Arden's theorem. What is Arden's theorem? If R equal to Q plus RP, then R equal to QP star is the solution, right? From this what you can write? So Q2, what is Q? Q1a, and what is P here? B plus AA star, right? Now this will be our equation 4, right? So now this Q2 is Q1a into B plus AA star is our fourth equation. Now we also have got the equation for Q2. Now where I can substitute this Q2 equation? Now I can substitute this equation 4 in equation 1. What is equation 1? Q1a plus Q2b plus epsilon. There I can substitute, right? There I can substitute. Now let me take, what is Q1? Q1 is Q1a plus Q2b plus epsilon. But what is Q2 we have got now? What is Q2? Q1a into b plus a whole star. B plus a whole star. Q1a into b plus a whole star. So this is Q2. Q2 along with what we have? B plus epsilon. Now we have to write B plus epsilon, right? Now if you simplify this, we get a plus a into b plus a star into b plus epsilon. We can also write Q1 is now epsilon plus Q1 into a plus a into b plus a whole star into b, right? Now it is like R equal to q plus rp. So again it is Arden's theorem. What is Arden's theorem? That Arden's theorem is that if r equal to q plus rp, then r equal to qp star is the solution. So then q1 r equal to qp star. What is qp? Q epsilon p star a plus a into b plus a whole star into b whole star. So what is this? Epsilon into r. So it is again like what? Another formula we can use. Epsilon into r is what? R. So then we can write q1 is a plus a into b plus a whole star b whole star. Now this is our equation 5, right? So now we have got the equation for this q1 also, right? But this q1 and q2 are the not the required equations. What is the required equation? That is q3 only. Now where you can substitute this q1 equation in the q2 equation? Where we have that q2 equation? So this is q2 equation. So now substitute equation 5 in equation 4, right? Let me take a new slide. Substitute equation 5 in equation 4. Substitute equation 5 in equation 4. What is equation 5 that we have seen now? This one. What is equation 4? This one. q1 is q1 a into b plus a whole star. q2 is q1 a into b plus a whole star. q1 a into b plus a whole star, right? So that is that equation for this q2. q1 a into b plus a whole star. Now we substitute this in this equation. Okay, what is that equation 5? This is q1. What is that q1 now from this? It is a plus a into b plus a whole star b whole star. Now we can substitute this here. Now what is this? A plus a into b plus a whole star b. What is this q1? A plus a into b plus a whole star b whole star. Whole star, right? Whole star. And what is that remaining? We have a into b plus a whole star. Now this is that equation for q2. This would be that equation 6, right? But this is also not the required equation. Now the required equation is q3. What we know, q3 is what? q3 is q2a. That is that equation 3. Now substitute 6 in 3. Substitute 6 in 3. We get, what is q3 now? q2a. So it is a plus a into b plus a whole star into b whole star into a into b plus a whole star a, right? So this is the final irregular expression for the given DFA. See, if you see that problem, in that problem also they asked us to show this. The regular expression for this is this one. So now we have proved this. Now we have proved this for the given minimized for the given DFA. The regular expression is this one. We have proved it, right? So let us go back to this. Let us see the problem that what we have done. Now in this problem, if you see, they asked us to prove this. The equation for this given DFA, the regular expression for the given DFA is this one. Now we have proved this. How we have proved this? Then we have started writing that state equations. Then how we have started writing the state equation. Then we have seen that paths of that particular state, how you can reach q1, how you can reach q2, how you can reach q3. So that is how we have written this equation. How we have written this equation? We can reach q1 with q1a, or q2b or epsilon, because why I am adding epsilon here, because q1 is initial state, so we can also reach to that q1 with epsilon also. That is the state equation of q1. How did I write q2? How we can reach q2? With q1 here we can reach, and with q2 there is a self loop, so we can reach q2b, and we from q3 also we have a path. With q3 with a we can reach q2. So this is the equation for q2, and q3 there is only one path, that is from q2 with a, so that is q2a. Now we know that from the given DFA, the final state is that q3. Now we have to find out the regular expression only for this q3, right? So now we what we have done to find out that, so here we have written the state equation. Now we have substituted that equation 3 in equation 2. So what is that? q3 is q2a. In place of q3 we have substituted this q2a. Then now we have taken this q2 as common, then we have got b plus a, q2 into b plus a. Now if you see this, it is like r equal to q plus rp, Arden's theorem formula. If it is like r equal to q plus rp, then qp star is the solution. That is why we are writing q2 is q1a into b plus a whole star. This would be the equation 4. Now where we can substitute this q2, wherever we have the q2, there you can substitute. Means in terms of q1, means if you substitute this in q1 equation, then again you would get r equal to q plus rp, then you would get q1 equation. So let us try to substitute this in q1 equation. This q2 is q1a, we can substitute this in q1 a into b plus a whole star in the q1 equation. Now if you substitute this in that equation, q1a plus q1a into b plus a whole star b plus epsilon, then if you take q1 as common, then we would get this. Now if you take that epsilon first, then we get, because epsilon plus r is also r plus epsilon, so then from this property we write epsilon first, then q1 terms next. Now again if you see this, it is like r equal to q plus rp. Again it is, the solution is qp star. So what is q here? Epsilon, and p is this one, a plus a into b plus a whole star b, now star, right? Now we know that epsilon into r is r, that is one property. From this, q1 is a plus a into b plus a whole star b whole star. Now we have got the equation for q1 also. Now substitute this q1 equation in the q2, in the previous equation. What is q2? This one, q2 is q1 a into b plus a whole star. Now we have got q1. Now substitute this in this equation. In the next step, if you see, if you substitute in that equation, if you substitute that in that equation, then we get q2 is q1a into b plus a star. That is what? That equation. Now what we know about q1, what is q1? It is a plus a into b plus a whole star b star. Next the remaining is a into b plus a whole star. So this is what? This one, this part, up to this part, it is q1. Now we have substituted that. Along with this q1 we also have a into b plus a whole star. Now we have got q2 equation also, but now we have to substitute this we have to find out the equation for final state q3. q3 is what? q2a. Now substitute this equation in that third equation. Now we have got q3 is, what is this? q2. Now this entire one is q2 along with that a, right? Now this is that final regular expression for the given DFA. Thank you all.